Hey guys, we're going to do 3D coordinate systems today. It's the first section of the semester. It's very similar to what you've seen before with X and Y coordinate systems, but we're just going to add a Z axis to it. And this is going to allow us to do almost everything we need to do in Cal 3. So let's get started. All right, uh, basically what you have here is you have the X and Y axes right here, X and Y. And what we're going to do is we're going to add a Z axis to it. All right, just a Z axis. And if you look at the outline of this hand here, so hang on one second. This is Z, this is X, and this is Y. Before, what you would have seen in your other classes is your X-Y axis here, X and Y here. And what we're going to do is we're just going to switch it around so that it's the X and Y, the Y axis is coming out of the plane. Out. Where's my pencil? Out of the page, out of the page, basically. And so Z is coming up. All right, so if you can see it, there's a hand here, and the hand here, there's a thumb, and here's some fingers curling. It's kind of hard to draw this. Anyway, so if you take your fingers and you run them along the x-axis, okay? If you run them along the x-axis like this, and you curl them toward the y-axis, let me just erase all this. If you curl them toward the y-axis, you're using your right hand, okay, your right hand. If you curl them toward the y-axis, your thumb should point up toward the z-axis. So just try this. You're taking your fingers here. Boy, where are my pencils? Fingers here. And then your palm here, basically your palm here. You curl them toward your palm and your thumb should point up. The reason that we talk about this is because we want in a little while to do what's called the cross product, and the cross product is going to require us to have this set up. All right, it may not make much sense right now, but it will. It will. All right, so we have now not just the XY plane. If you look here, we have not just the XY plane, but we have the XZ plane and the YZ plane here. So X, Y. This is your normal XY plane. This is what you see in algebra. And then we're going to add to that the YZ plane and the XZ plane. All right. So how do you plot points in this? Well, let me show you. Come over here. The way you plot points is, let me draw this. So here's your X and Y and Z always come this way. Now, I was talking to the physics professor, and she said that Z goes out that way, and Y goes. It was X and X was here, and Y was here, or something like that, and Y was there, and X was there. So it's going to be different in your physics class, maybe. So let's plot a point. Let's see. Let's plot 2, 4, and 6. Okay. So to plot 2, 4, 6. We're going to go out 2 in the x, so this is going to be the point 2, 4, 6. So we're going to go out 2 in the x direction. This is the x coordinate. Out 4 in the y direction. So this is 4. So out 2, over 4. We're going to go parallel to the y-axis. So right here, this would be 2, 4, as you know from before in your algebra courses. And now 6, we're going to go up 6 in the z direction. It's not to scale. So we're going to go straight up, and then we're going to plot a point. We'll call this point P. This will be point P. Now, the way you draw this is the way you draw the point P is you're going to have to draw a dotted line to the 0, 0, 0 point. And now Z, let me erase Z for a second. Let me erase this. Let me draw this more to scale. If you look, I'm going to draw a line from P to the Z axis that's parallel to this line down here. And that's where it ends up. So this is 6 on the Z axis. This is Z axis here. Okay. So that is the point 2, 4, and 6. All right. And that's how you draw a point in 3 dimensions. Now, these other ones here are much more difficult to do, like this one here, because it has a negative number in front. It has a negative number. We have surfaces that we're going to be discussing quite a lot in this class, and the first 2 surfaces we always discuss are planes. So let's talk about planes for a second. So if you want, I'm going to go back to college algebra for a minute, and we're going to talk about, actually we're going to go back to kindergarten for a minute, if you don't mind. Remember from way back, they said plot the number, let's say 3. Okay, so you would take your number line and you would plot. Here's 0, there's 1, 2, 3. You would plot 3. There would be a point there. Okay, so that would be 3. You have 2, and you have 1 here. Okay, so that was whenever you dealt with 1 dimension. Okay. So then further down the line, you dealt with 2 dimensions. So this was maybe junior high, okay? Or maybe elementary school. I don't know. It's been so long. So now, if they say plot 3, it's there, because now you have a y-axis, x-axis. So essentially what you did was you took the x-axis, they didn't call it the x-axis, this was called the number line before. And you made a copy of the x-axis, and you rotated it 90 degrees. You made that copy, rotated it 90 degrees, and you called that the y-axis. Okay. So anyway, here's 3. Now, when you dealt with this stuff in junior high, when you started doing algebra or geometry, whichever, they said x equals 3. Well, x equals 3 is the line. Let me do a different color. X equals 3 is the line. This is 3. So it's the line that contains only x values is 3. All the x values are 3. Boy, that's a terrible line, isn't it? Let me draw that again. So this is the line x equals 3. And it comes from that number line from before. You just create a bunch of dots in the y direction and you get x equals 3. Okay? So, this was in algebra, x equals 3. Remember, when you find the equations of lines, x equals 3 was a vertical line parallel to the y-axis. Now, notice in this equation there is no y term. If there's no y term, then the figure is going to be parallel to the y-axis. We're going to need this. So, for example, if you had y equals 2, there is no x term. So, if you look, no x term parallel to the x-axis, no y term parallel to the y-axis, okay? All right, so you learned that in algebra. So now let's move into Cal 3. So I'm going to draw the x, y, and z axes, and I'm going to go and I'm going to plot x equals 3 there. So when I plot x equals 3, actually let me do these in red. Just consistency here, y, x, z. All right, so 1, 2, 3. So I'm going to plot x equals 3. So x equals 3 is going to be that line still. So just like I drew the line before, so I drew the point, and then I drew the point there, and when I was in 2 dimensions, I just continued that point along the y-axis. And now what I'm going to do is I'm going to continue this line up in the z direction. And if I continue this line up in the z direction, what I get is a plane. So basically, I'm continuing this line in the z direction. And so what I get here, x equals 3, is a plane. 3. Okay? So this is a plane that's parallel to the z-axis. All right? Parallel to the z-axis. And it's also parallel to the y-axis, to y and z axes. All right, so essentially what we have here is a system by which we can plot things in 3 dimensions like we had before in just 2 dimensions and before in just 1 dimension. So it's the same thing, except now what you didn't realize was this dot in your elementary school class, that dot there, was really part of a line, all right? And then that line was part of a plane, all right? So, and that plane is also known as x equals 3. So if you wanted to graph, for example, let's say y equals 2, okay? So now plot y equals 2. You would take your x, y, and z, like you had before, and you draw y equals 2. Suppose this is 2 here. And you're going to keep drawing lines like that line that are parallel to it. And let me just, what you do is you draw straight up, and then you draw a line. The top of the plane will be parallel to the line below. And so this is your new plane, y equals 2. All right, got it? So let's move on to other things. Let's see here. Yeah, so they did that there. All right, so it says here, I don't know if you can read it, it says describe and sketch the surface in R3. R3 is now the x, y, and z coordinate system. R2 was just the x and the y. Like you see x and y here, x and y here. This is R2. It's R2 because it's R cross R. The number line and then another number line. So this is 3 number lines together. So what we're doing here is we're going to sketch the surface in R3, like I said. And what is it? X plus y equals 2. So let's move over, and it looks like a mess. So here we go. We're going to sketch x plus y equals 2. So first you want to graph. See, there's no z here. There's no z here. So first what we're going to do is we're going to graph it in 2D, like we did in college algebra, or just algebra. So here's the slope. M is -1, and the y-intercept is 2. So here's 2. Slope is -1. So slope of -1, maybe that's this right there. All right, so this is y equals -x plus 2. All right, now I'm going to take this and I'm going to graph it now in 3 dimensions. So here we go. So let's draw our axes. Here's x, here's y, and then we got z. And I'm gonna draw that again. All right. So if you turn it around, this is the x and this is the y. If you turn it around, I think it will look like this, something like this. This line is now there. All right. And it doesn't look like much of a line, does it? Let's start over. All right. So there we go. All right. Well, that's good enough. All right, so now what we're going to do is we're going to assume that this line continues on up. And it's going to be parallel to the z-axis. This plane is. And so what you want to do is the very top is going to be, you want to make it parallel to that bottom line. And now you have your plane. So in R2, this was a line. But in R3, 3 dimensions, this is a plane. And that's how you draw it. Okay, so these guys right here, these are called rulings. We're going to get to this later, but it's good to know the word now. These are called rulings. And this is going to be helpful whenever we have to graph things like this guy right here, x squared plus z squared equals 9. All right, so in algebra and geometry, this was known as a circle. So let's pull this over. It's x squared plus z squared equals 9. So let's keep going with this. We're going to graph x squared plus z squared equals 9. Okay, so in the xy plane from your previous courses, this was a circle that was centered at the origin of radius 3. And because 9 is 3 squared. Remember the formula for a circle was x squared plus y squared equals r squared. The center here is 0, 0, and the radius is r. Radius. Okay, so now it's the xz axis. Okay, so what we're going to do is we're going to take that circle and we're going to draw it in the xyz plane. So this is negative y, this is negative x, and this is negative z. X, y, and z. So what I'm going to do is I'm going to draw it in a different color. So it's in the xz plane. Xz plane is this one here. So in the xz plane, it would look like this. Oh, it's a rainbow one. Okay. So it's this circle right here. All right. So I've just drawn that there. Let me get out a rainbow. This is bizarre. So whenever I draw rulings, these rulings are going to be parallel to the y-axis. Why? Well, because there's no y in this equation. There's no y. Why there's no y? I don't know why. Anyway, stupid joke. No y, so you're going to draw the same object parallel to the y-axis. It's over the y-axis. The rulings are parallel to the y-axis. So essentially what you do is you just draw your circle and then you just continue that circle out in the direction of the letter, the axis, that is not represented in the equation. So since there's no y, it's parallel to the y-axis. It's going in the y direction. All right. So what is this called? This is just a cylinder. So what you didn't know in your algebra class was when you drew a circle, it was just part of a cylinder. And there you have it. So now let's go back to the page and let's see what else we got to do in this section. Which points satisfy the equations x squared plus y squared equals 1 and z equals 2? Well, basically what we have here is we have a circle. X squared plus y squared equals 1. So that's here. But that is in R2. So in R3, this will look like the following. Well, let me draw this in a different color. All right, so we got this circle in the xy plane. Here's x, here's y. And now this circle, I'm going to draw it. That's the circle in R2. That's this guy right there. There it is. Okay. Now I'm going to draw it so that it is parallel to the z-axis because why? Because there is no z here. No z. So draw parallel lines to the z-axis, and so now we got a plane. All right, now we're looking at an intersection here. It says and. This is intersection. So and z equals 3. So I'm going to draw z equals 3. Z equals 3 is the plane at 3. This is z equals 3. So that's a plane. Why is it a plane? It just goes back to what we talked about up here. Z equals 3 is this plane here. So study this. Study that right there. All right. So z equals 3 is this plane. The intersection of the cylinder and the plane is just this circle right there. So it's a disk. So when you draw it, when you actually draw it, let me use a different one. You're going to get just a disk. And that disk is at z equals 3. All right, so that's the intersection of those two. All right, so let's move on. So we already did this one. And, oh, there's the answer that we did. That's the one we did. So, all right. Now, the distance formula, I'm going to let you do this. You do this. And then we've got equations of spheres. So what this is right here, this is easy. Basically, if you look from algebra, we had a circle, algebra and geometry. We have a circle equation as x minus h quantity squared plus y minus k quantity squared equals r squared. If you don't remember this, just look it up in an old textbook if you want, or just Google it, equation of a circle. This is h and k were the center, and then r was the radius. Okay, so in 3D now, we're just going to add another dimension to this. Okay, so it's going to be x minus h quantity squared plus y minus k quantity squared plus z minus, well, now we're not going to use h and k because we're running out of letters. It's x minus x1 squared, y minus y1 squared, z minus z1 squared, or x naught. I think it's naught. Do they use naught? Oh, they're using z minus l. That's not standard. Let's use x naught, y naught, and z naught equals r squared. So now this is a sphere of with the center at x naught, y naught, and z naught, and the radius is still r. Okay, so essentially, if you want to get the equation of a sphere that is, let's say, so you draw a sphere. So whenever you're drawing these 3D objects, a lot of times it's easier to draw the object first and then the axes. Oh, there's that rainbow one again. All right, I guess it's here to stay. So this is the sphere, x squared plus y squared plus z squared. And then we're going to say maybe the radius, maybe this hits at 3, is 9. Okay, so that's spheres. All right, one last thing for this stuff. You can have a restriction to it. If you look, this is a sphere. And the inside, and it looks like it's going to be, the radius is going to be greater than 1 and less than 2. So it's a solid sphere. And I'll let you study that. So you start. All right. Now here you have spheres that aren't given so nicely. Okay. So for example, number 14 here, it says find the equation of a sphere with center 2, -6, 4, and radius 5. So you're just going to use your formula here. and you're going to plug in numbers. So it's going to be x minus 2 squared plus, and then y minus a minus 6, so that becomes a plus 6 squared, and then plus z minus 4 quantity squared equals, the radius is 5, so 25. And there's your answer for that. Now, if you look, this sphere equation down here is not so simple. It's not like that. So what you're going to have to do is make it look like something like that. All right. So what you'll have to do is you'll have to complete the square. You'll have to complete the square to get there. And there's probably a problem in the book. I'll go ahead and do this one for you if you want. Completing the square is something that a lot of times is not gone over much. So we have x squared plus y squared plus z squared minus 2x minus 4y plus 8z equals 15. So what you're going to do is you're going to group the x's together. So it's going to be x squared minus 2x plus y squared minus 4y plus z squared plus 8z equals 15. All right, now I'm going to take the x's. I'm going to take that negative 2. I'm going to divide by 2, and I'm going to square it. On the y's, so basically you get negative 1 quantity squared equals 1. All right? So then in the y's, you're going to take the negative 4, so negative 4, you're going to do the same process here, divide by 2 and square it. So it's negative 4 divided by 2 is negative 2 squared, and then this is 4. And so for z, you're going to get, what was z? Z was 8. So 8, you're going to divide it by 2 and square it. Now the reason for all this is in an algebra course. I'm not going to go into it. You can Google complete the square, and maybe Wikipedia will show you. So we have 1, we have 4, and we have 16. So what I'm going to do is I'm going to take all those, I'm going to add those to the left-hand side of the equation. So let me erase all this. 1, 4, and 16. So I'm going to take x squared minus 2x. I'm going to add that 1 plus y squared minus 4y. I'm going to add that 4, and then plus z squared plus 8z, and I'm going to add that 16. Now if I add it to the left, I got to add it to the right. So equals 15 plus the 1 plus 4, and then plus the 16. All right. So on the left-hand side, when you factor the x term, you get x minus 1 squared. When you factor the y terms, you get y minus 2 squared. And when you factor the z terms, you get z plus 4 quantity squared, like that. All right, and on the right, you get, let's see, 15 and 1 is 16, plus 16 is, so what you get here is the equation of your sphere and what's its standard form. So the center is 1, negative 2, because this is z, this is 2, negative 4. It's negative because this is a negative negative. If you look at the formula has a negative here, okay? So the center is 1, 2, negative 4, and then the radius is 6. And there we go. That's how you do those. So is there anything else in this? Probably not. And that's your 3D lecture right there.